Math 6620. This is going to be our final example for log linear analysis. Get things. And I tried to choose something that's education research based here as the final example. I got to tell you, to prepare for this example, and I don't even know what's going to happen. I've chosen a data set and tweaked it a little bit, but I think I know generally what's going to happen, but I don't know specifically what's going to happen with certain things. But it took me about 35 minutes to prepare for this, and it took me about an hour and a half to work out the kinks in R. So just thought you should know that. I don't know why. All right, let's get to this. Let's say that we've collected some data, in this era of online instruction and flipping classrooms and different things. So we're going to examine the effectiveness of the delivery of some classes, or I should say class, and we are looking at the difference between success rates of lecture delivery and online delivery. And let's just say, for the heck of it, that we have the following responses. So 28 people who were delivered the course via lecture succeeded, and so on and so forth. And we'd like to test this. Now, I want to tell you later on, I'm going to bring in a third component here, a third variable across professor, actually across professors A and B, but we'll leave that for later, because again, I want to go through this illustration pretty thoroughly for you guys, okay? So first of all, what I would want to do here is officially state the null and alternative hypothesis. So we would say there's no relationship between delivery and success. And the alternative hypothesis would obviously be there is a relationship between delivery and success rates. Now, this is just a very, very simple approach just to kind of get the ball rolling about what we're going to do. We're eventually going to get into log linear analysis, but first of all, with only two categorical variables, we could run the log linear analysis, but guys, when you only have two, let's keep it simple. Let's look at chi-square, and we'll save log linear analysis for when we have three categorical variables or more. So log linear analysis is kind of the topic of choice for examining categorical data, but chi-square techniques are preferred, at least by me, and that's the way I'm going to illustrate it in this video. They're preferred when we have two categorical variables. All right. So, gang, let's get the ball rolling. Let's go over into R and start examining our data. So I'll get rid of this. Not completely, but sorta. And I think I've already got an R up. Yeah, I do. So I've already set the working directory here, but really I'm not going to I'm not going to approach this part of the analysis using a file that I have on my desktop. So what I want to do, I want to just to demonstrate this way of doing things. I want to call lecture the counts that we have of 10 and 28. Now, let me point something out to you that I do from time to time, that I usually do. You'll probably, if you look back at what we had before, you'll notice that reading top to bottom, it was actually 2810. But I like to typically let my no's always be 0 and success be 1. So I kind of think about this in my head as you know, the 0's coming first, 1's coming second. It doesn't matter. Things are going to work out the same, but it's just a kind of a Darbro-ism, if you will, that I like to. And I guess I kind of got into this with the logistic regression, but I like to have things in terms of what I'm thinking in my mind is what my 1's are. So. No big deal. All right, so next thing I'd want to do is I'm just going to call this online. And I'm going to bind, I think it was 114 and 28. Guys, let me check that and make sure. 114 and 48. It's a good thing I did that. All right, next thing I want to do is I want to just create something I'll call delivery. And I'm going to cbind lecture in online. And everybody likes to see the fruits of their labor, so you can see what we've got is exactly what I gave you before. Just difference is the 0's and 1's are flipped. All right, so guys, the first thing I'd want to do is run just a simple chi-square analysis. And that requires the cross table, but guys, remember there's two libraries that we need to install or access. Number one is gmodels, and we're also going to need the library for the mass. Okay? Okay, my bad. I didn't think that rolled off. Oh, okay, I see what's going on. Should be gmodels. There we go. Okay, so we've got the libraries installed that we're going to use. Gmodels, not ggmodels, and library, all caps, in mass. So, guys, let's go for it. I want to run a cross table, and I want to run this on delivery, which I created before. I want the Fisher test statistic. I want the chi-square test statistic. I want my expected cell counts. Let's see, what else do I need? I definitely want the standardized residuals. And, all right, that should do it. If you don't have much experience with SPSS and SAS, then this last part doesn't really make any sense. Just remember, if you leave format equal SPSS out, even if you try to recall your standardized residuals, they won't show up. So, anyway, that's what we get here. Okay. Now, the first thing I'd want to do is kind of just statistically describe, and this is before I get into anything. Anything too crazy, all right? So what I would like to do here is just just statistically describe. So when I read left to right, remember this is not succeed. So in this situation, we have that 91.93% didn't succeed, who were versus 8.065 in lecture. Now this row down here is actually succeed. So for lecture we had, let me make sure I've got row percent, 36.8% who succeeded, 63.16% succeeded there. If you compare the other way, you can see across lecture the percentage who didn't succeed versus the percentage who did succeed, drastically different. So. you know, something to actually to keep in mind. But guys, I'll tell you, be perfectly candid and honest with you here. I am automatically drawn to the standardized residuals. And the two standardized residuals that I see that are most concerning for me is the negative 2.79, which is the non-success for lecture. This tells us that the observed cell count is 2.79 standard errors less than what we would have expected under the null hypothesis. And this tells us that the observed cell count for those who succeeded in lecture was 3.6 standard errors higher than we would have expected under the cell count. Now, the success rate is fine in terms of being if you were an education researcher, but the high percentage that didn't succeed is well, no, wait a minute. This says under lecture that the observed cell count is less than. So actually, this from education researcher perspective, that's welcoming news. Odds ratio, you can see that our odds ratio is 0.15, and we have statistical significance. And anyway, I would go through this. I would describe the rows and columns. I would go through and make sure that all of our expected cell counts are bigger than 5. And you can see down here this says the minimum is 14.44. So that's an easy way to observe that. My eyes would then be drawn directly to the Pearson chi-square, not with the Yates continuity correction. We don't need that in this situation. And I explained that back in an earlier video. But the Pearson chi-square test, we can see that the test statistic is 25.4, and we have statistical significance at the 0.001 level. Next thing again, examine the Fisher exact test. I'm only going to care about the true odds ratio not equal to 1. And you can see that 1 is not contained in our interval, our 95% confidence interval, which leads us to know that we're going to have statistical significance, which is indicated by the p-value. And this, in many ways just confirms what we have up here with the Pearson chi-square test. So guys, what we can come up with right now is there is an association between delivery method and success rate. And now, I guess as Paul Harvey would say, let's tell the rest of the story, because the details of this association actually come out in the rest of the analysis. So, guys, the first thing again I would want to do is analyze the standardized residuals. And as we talked about earlier, these two are bigger than the absolute value of 1.96, namely 2. So those draw attention. So the cells that I'm looking at, which have the most contributing power, not statistical power, the contribution power in terms of chi-square statistic, is that those who didn't succeed in lecture were lower than what we kind of expected it to be, and that's fine. But the problem here turns out to be that there's a higher number that we observed who, well, it's not a problem. Actually, this is so the observed cell count for those who succeeded in lecture were 3.6 higher than we would have expected under the null hypothesis. All right, so let's dive into this a little more and see what happens. So, guys, it looks like that the association between delivery and success is mainly driven by the delivery when it's equal to lecture. The online doesn't seem to be doing a lot, but there's quite a bit going on with this lecture deal. So let's dive in and get some more information. Now, if we go back up here, looking at the observed cell counts, let's let's take a look at something. So I want to get out of here, and I want to go back to this. All right, so as we talked about in an earlier video, we could examine effect size from here, and we do that by odds ratio. And to me, the drum roll please, the aha moment comes when we look at this. So first of all, I would want to examine the odds for success across lecture. And this is 28 over 10, which is 2.8. The next thing I'd want to do is I'd want to look at the odds for success over online. And let's see, those that succeeded online were 48 versus those who didn't succeed online were 114. So I've already gone ahead and put this in my calculator to be equal to 0.421. So guys, this leads us to the most important thing that we get, at least in my opinion, other than maybe the chi-square statistic, is the odds ratio, which is 2.8 over 0.421, which is 6.7. So what we can say here is we can say that if a student took the class via lecture, their odds of success were 6.7 times, almost 7 times higher than for a student who took the class online. So again, our focus right here is on the lecture part, and that seems to be driving the statistical significance in the driving the magnitude of our chi-square statistic and the statistical significance. Now, guys, if I wanted to stop here, and there's nothing wrong with that, if I just wanted to take a look at the relationship between two categorical variables, it happens, and that's okay. But what I would say something to the effect, and we're going to get to the good stuff in just a second. I would say there was a significant association between delivery method and success rate. And guys, these success rates were actually C or higher. Okay, let's see, we had a 1 degree of freedom. Our chi-square statistic, our Pearson chi-square is 25.36, and we had statistical significance at the 0.001 level. The association, as indicated by the odds ratio, appears to represent the fact that the odds of a student who took the class as a lecture let's see, I'm getting caught up in my words here, appears to represent the fact that the odds of a student who took the succeeding were 6.7, right? Yeah. higher. Guys, I also, if you could get the confidence interval here, were higher than for a student who took the class online. Now, guys, don't go out here and publish this stuff or to go around telling people that I'm in Darbo's stats class. And we found out the other day that online courses aren't as effective as a traditional lecture. I'm making this stuff up as I go. One thing I want you to notice here is the way that that this could be a source of confusion. When you there's my dog. All right, hold on. All right, just like clockwork. You notice that the odds ratios that I have presented here weren't 0.15, but I think it goes without saying that if we take 0.15, 19927, and take the inverse of that, because this is, the way I set this up, this is the odds ratio of not succeeding. That's just the way that R, whatever you give it first, that's the odds ratio is going to be calculated on. So if you take, I'll tell you what, let me just do this. If I take 1 divided by 0.15, 19927, this probably didn't even need to be explained. But you get 6.6, within rounding, the odds ratio that I reported the other way. And you could do the same thing here. To get the bounds of the confidence interval, you can take these and you'll have to reverse them, but that's where I get the bounds of the confidence. Because what I want to do, I want to talk about in terms of success and not odds of not succeeding. So that's the only reason for that. All right, gang, let's let's get into some good stuff. I'll tell you what I'm going to do, just so there's no misunderstanding. I'm going to quit R, and I am going to get back into R. I don't like any chance of getting any confusion. All right, so if I just take a look at the data I have on my desktop, and this has been uploaded to Blackboard. All right, hard for me to to type and think. So, guys, you've got an extra variable here. We still got delivery and success that we had before, but and I think we can just look at this as delivery, success. That's not going to work, is it? Well, I forgot what I need to do to look at that. I thought it was X tabs. Well, anyway. I could break this down and just look at over delivery and success. No, it's not going to work because we have three. It's going to take the entire data frame, so we're going to have to do something different for that. So, so guys, what I want to do, I'll tell you what. Let me just show you the whole data set here. What I've got here is there's a sample size of 270, and you can see what's going on here is you just have the same information we had when we looked at the 2x2 in delivery and success. But now we've got some information provided across professor. And we kind of got to wonder is if the overall results of the delivery method and success rates, maybe they aren't being masked by one professor who's better at one over the other one. So there's that chance, and that's something, if you were an education researcher, that you would definitely want to investigate. Well, in a nutshell, that's what we're going to do right now. Okay, so hang on for the ride. Guys, the first thing I would want to do is remember the cross table can't handle 3 variables. So we need to break that down into 2 variables. And what I'd like to do is look at this across professor. So I'm just going to go just A for just professor A. And I'm going to set up a subset from the data frame data. And I want prof equal A. Now, guys, I don't know why, but if you just put 1 equal sign there, it won't work. It'll give you the entire data frame. But to actually isolate this just for Professor A, we have to do that. Guys, I want to do the same thing for Professor B. Set up another data frame from the initial data frame. And go, yeah. Now, just to make sure, let's just go just A, and you'll see that we just have the first 200. And if we go just B, clearly we have the next 70 for Professor B. So we want to examine the effect of the Professor A and B brought into our model that we just explored. So guys, we got these two new data frames, just A and just B. So what we can now look at is we can look at the cross table for just A. Across delivery, just A, across success. And, you know, for now, I just want to look at let's see if that's what I want to do. Yeah, for now, I just want to include the standardized residuals. I'm not really worried about the chi-square statistic. I just want to look at this stuff, okay? Now, well, that's just lovely. Oh, guess got caught. Happens to all of us, right? All right, gang. So after we install or access the library, what we can see here is, again, we just have this now for Professor A. And for Professor A, what I see is there is a drastic difference between success and not success across lecture. Not so much online. Both of the standardized residuals here are not exceeding 2 or negative 2, the absolute value 2. But this tells me that the observed cell count for those who did not succeed, and again, this is just in Professor A's class, for the lecture component were 2.79 standard errors below what we would have expected it to be under no association. Professor A also has an observed cell count for those who did succeed under lecture to be 3.6 standard errors higher than we would have expected it to be under no association. All right, so kind of cool stuff. It tells us that Professor A seems to be productive when, let's see, we have, so 70, I'm trying to see what's going on here, 74% of students succeeded in lecture, where only 26 didn't. So, and then 70.4 didn't. We got a larger sample size down here. That's the reason for the difference. And okay, all right, that's cool. All right, so let's go back and let's do just B. See what happens with Professor B. And when we look at Professor B's, okay, I didn't expect this. Okay, I see what's going on now. If you look at the standardized residuals for Professor B only, none of the values are higher or lower in terms of standard errors than we would have expected them to be. So right now I'm thinking that this is all about the the difference in success rates across delivery method, to me, appears to be all about these two cells right here, all about success rates for the lecture component for Professor A. In fact, it looks like that the success rates for the lecture component are a lot higher than we would have expected them to be. All right, but let's go ahead and let it happen. We'll go through the full delivery of this analysis. Guys, next thing I'd want to do is set up a contingency table. So I want to get serious now, and I want to get into the log-linear model and see what's really going on here. But remember, log-linear model doesn't you can't create that from your initial data frame. You have to create a contingency table. So I'm just going to call it table, for lack of a better word, and I'm going to use X tabs, and I got tilde, and I want prof plus delivery plus success. Now, guys, let me explain something to you here. Whichever one I put last, that's the one that I'm going to quote unquote, I guess focus on. That's really what I want to know. If I was interested in this online versus professor, I would ultimately be looking at the success rates. So whatever I put last here is ultimately going to be what I focus on. Let me show you why that works out that way. If I come in on the table, notice what it's going to do here. It's going to create, based on the first two, the professor and delivery, it's going to give me my counts, but it's going to provide these over the success rates of yes and no. Now, there may be a strong argument that, considering what we found earlier, we probably should have put professor there to see what happens there. But guys, we'll go ahead and run it this way. And that brings up a really good point. When you're doing, of course, right now this is an academic exercise, something we're just learning from. But once you get involved in things, if you ever do, that really matter to you, you've got to become a kind of a laborer, if you will. Remember back when we were doing factorial ANOVA, and I told you there were different ways that we could look at profile plots by changing things around. It's kind of the things you got to do here too, because these are so closely related, in my opinion, to a factorial ANOVA. But enough of that. Let's make it happen. First thing we want to do is run our saturated model. And I'm not going to have a lot going on here, so I'm just going to call it saturated. And I want my log linear model. And guys, I want the prof times delivery times success. So I'm looking at the, guys, remember, you got to use your contingency table here, not your initial data frame. So what we're doing here is doing, again, we're looking at the highest order interaction, which would be the three-way in this case, all right? So I want to look at summary of saturated. And almost always in this case, you will not get statistical significance. All right, all this stuff is fine and dandy, but my eyes are immediately brought to the likelihood ratio of 0, p-value 1, which is non-significant. So non-significant just tells us that this is a valid model for explaining the phenomena. Next thing I'm going to want to do is I'm going to focus on my mains and my two-ways. So I'm going to just keep going, and until I find non-significance. Until I find statistical significance, in which case I return to the previous model that was not statistically significant. So guys, I'm just going to call this model 1. I honestly don't know what's going to happen here. I think I do. So I've got log linear model, and I want my main effects. So I want prof plus delivery plus success. And then I want prof delivery prof success and delivery success. Data equals, sorry, table is what I called that, right? Yeah. So guys, go summary. So drum roll, please. All right, so guys, we come to our p-value. So this change says that my change in the likelihood ratio, which went from 0 to 20.31 under degrees of freedom 0, because we also subtracted degrees of freedom, is statistically significant, telling me that my full model is where my focus should be. Now, what would happen if this had been not statistically significant? What I would need to do then is I'd need to come up here and examine the change in the model. I first of all want to start taking out these two-way interactions one by one and see if any of those led to non-statistical, or I'm sorry, led to statistical significance, which means, again, I would return to the one that wasn't statistically significant. So, guys, we have statistical significance, and again, you can calculate this by just subtracting the likelihood ratios and the degrees of freedom, calculating the p-value, or you can be lazy or clever, however you want to look at it, and look at the difference using the ANOVA function. And notice model 1 had deviance, model 2 we started with had a chi-square likelihood ratio of 0. Here's the delta, that's the change in the deviation, and we have statistical significance, which means the model that we started with is the one we need to focus on. So again, the statistical significance tells us that the model got worse when we went from the full effects, or I'm sorry, the highest order interaction to the two ways. Well, guys, now it's when it gets fun. We got something going on across delivery, success, and professor. So we need to focus on all three. Now, I think a good way of doing this is to look at a Mosaic plot. And I want to take my table, and let's go shade equal true. Okay, what's going on here? Well, the first thing I see is this is a big rectangle. And I also see that it's not dashed, so this tells us that the observed cell count is higher than the expected cell count. So for Professor A, those who succeeded online, no, I'm sorry, who didn't succeed online, this is interesting. Was, let's see, I can't tell whether that's that blue or that blue. I'm having a hard time here. It looks like 2 to 4. Looks like this matches up with that. So the observed cell count is somewhere between 2 and 4 standard errors higher of those who didn't succeed online than we would have expected under the null hypothesis. Instructor B over here, notice that across lecture, no's and yeses, not a lot of difference in the size of those rectangles. A little bit going on down here, but guys, it looks like to me that our focus here is dealing with Professor A and the difference in success rates across lecture. Well, primarily from lecture, those who succeeded in lecture to those who didn't succeed in lecture, and also for those who did not succeed online versus those who did succeed online. That's interesting. Looks like to me Professor A needs to strongly consider which kind of delivery he's going to actually take a look at. So, but I think, you know what? I'd like to look at this more. Let's. This is really intriguing to me. I'd like to look at. I'd like to look at this, the cross table. So what I'd like to do now is I'd like to come in and just conduct just a straightforward chi-square across delivery and success, but I'd like to look at that across professors for A and for B. So guys, I want to come in and add some stuff here. First of all, I want to add Fisher equal true, and I would like to add obviously chi-square equal true. And I want to take a look at my expected cell counts, make sure we don't have any, let me make sure I got everything typed correctly there. Make sure that we don't have any, okay, that looks good. All right, guys, let's run it and see what happens. So first of all, notice for Professor A that again it's coming down to this to this lecture. Chi-square statistic is statistically significant. Odds ratio is 0.15, statistically significant. I'll tell you what. Let's go back and look at B. I'm kind of rambling right now because I'm actually finding this kind of interesting. And I bet what we do here, I bet we don't find anything. Well, we are statistically significant, 3.93, but you know, the p-value is bordering right around the 0.05 threshold. None of the observed cell counts or the standardized residuals are greater than the absolute value of 2. So guys, it appears to me that this difference in success rates across online and in class or typical lecture, it looks like to me it all comes back to the impact that Professor A has in this study, because again we can see that that he's having tremendous success in the classroom under lecture, but he's having completely horrible success when he teaches online. Whereas the success rates, well, Professor B does as well, but he's having success online, and we got lower cell counts too. So notice our 95% confidence interval for the odds ratio contains 1, so it's not statistically significant. All right, guys, this one's going to be it's going to be interesting to write up. First thing I'd want to do here is I'd want to take a look at the odds ratios for success. Wow. Okay. So let me go back over. I'm gonna keep this here. So for Professor A, we have lecture online, and I'm writing some stuff down. Success and no. So So lecture, no, was 10. Lecture, yes, was 28. 114, no. And 48. All right, so let's come down to B and get that information here. And then we'll go back over to the all right, so online no was 7. Online yes was 29. Lecture yes was 20. And lecture no was 14. All right, so again, I think odds ratio is the place we need to be going here. This has turned out to be a really, really cool example. I can't believe it's worked out this way. All right, gang. So let's just focus on Professor A. So the odds of success for lecture are going to be 28 to 10. Well, these are turned out to be the same. And odds of success for online were 48 to 114. I didn't realize this, but before that data set must have just been for Professor A. Because these numbers are very, very, very familiar. So 0.421. Yeah, that's what's going on here. So guys, when we have 2.8 divided by 4.421, yeah, we get the 6.7 that we saw before. So the odds of success for Professor A lecture are 6.7 times higher. So yeah, this is making a lot of sense. Okay. Now, Professor B, which we have right here. So the odds of success for lecture are 20 to 14. .429. And then the odds of success for online are 29 to 7. That's 4.14. So 1.429 divided by 4.143 gives us 0.35. All right. Now another way of thinking about that is we could take 4.413, because this tells you that the odds of success is 0.35 as high for this. Again, this is Professor B. 0.35 times as high for lecture as it is online. If we want to focus on more of a an odds ratio above 1, we could take the 4.143 divided by 1.429. So the odds of success for a student succeeding online, okay, this is why the chi-square statistic was 0.046 for Professor B. It's becoming more and more clear as we examine this closer. When you take 4.143 divided by 1.429, you get essentially 2.9. So the odds of success for a student taking an online course from Professor B is 2.9 times higher than the odds of success for a student taking a lecture. So that's really interesting. This is going to be a beast to write up. I'll just go ahead and tell you. I'm not even looking forward to it. But guys, we got to do it. This is where I wish I could say, and as a class exercise, you guys tell me what you think, but I think that would be cheesy. So guys, let's try to write this up, okay? So I would say that starting with a summary here. So I would say a three-way log linear analysis. Produced a final model that retained all effects. The likelihood ratio of this model. Which was chi-square degrees of freedom 0 equal 1. No. P-value equal 1. Indicates the highest order interaction which is delivery across success across professor was significant. All right, let's see. I think don't know why it does that, but it just does. All right, separate chi-square test. Now we're examined. On success and delivery. Across professor. Professors A and B. For Professor A, there was a significant association between delivery and daggone it. All right. Between delivery and success. Now I'm going to have to go get that. So, but guys, for Professor A, let's see what happened. All right, so Professor A, we have 25.36. And p-value was less than 0.001. We're going to have to go back and get for Professor B, but that's cool. All right. Let's just say this was also true for Professor B. And let's go get that information. All right, gang, for Professor B, I know this is kind of cumbersome, but our chi-square statistic was 3.93, degrees of freedom 1. And our p-value just barely squeaked in at the 0.05 level. Now, so I've already noted that here. And really, at the end of the day, when you say this, when you say that the chi-square statistic is we have statistical significance, it really doesn't tell you anything until you look at until you examine the odds ratio, because you don't know where the difference is. You don't know which is contributing to the difference. So I would say computer's got a lot going on here. I would say something that the results indicate a significant difference. And success rates. Across delivery method. For profs A and B. More specifically, the odds of success for a student taking a lecture class from Professor A is 6.7. We did those calculations. Let me see if I can find them. Let's see. Okay, here they are. We're 6.7 times higher than for a student who took the online class from Professor A. Professor A may be a great professor, but it seems like this person is having some major difficulties with the online component. Whereas, the odds of success for a student taking the class as a lecture from Prof B are 0.35 times higher than the odds of success for a student taking the online. So guys, I don't know about you, but it seems to me that if you're going to take an online course, you need to take it from Professor B. And if you're going to take a lecture course, you need to take it from Professor A. All right, guys, that's all I got for you. This is a lengthy video. Gonna keep this success delivery stuff on the back burner. Next thing on the agenda is going to be logistic regression, statistical technique that we encounter a lot in education research because of obvious reasons: success, not success, retained, not retained. Just different things that we run into in education. So, guys, that's it. Take care.